he needed. With the electronics taking shape, it's time the legs do as well. So Mike is heading over to Finish Line Composites for a meeting with the doctor, Dr. Carbon Fiber.
Kim's has done it all with carbon fiber, and somewhere along the line he got the name Dr. Carbon Fiber.
Hey, what's going on, Mike?
Hey, James.
How's it going?
Yeah, it's going good.
Cool.
Beautiful day for making, oh my, that's a lot of carbon fiber.
Yes, it is.
Armed with enough boxed up carbon fiber to build a small spaceship, the guys launch into the job. Building the perfect leg is a long and tedious process. The first step is to cut the carbon fiber into carefully measured pieces, which get puzzled together in the shape of a square. This is just one layer. And to support up to 400 pounds of robot, Mike will need 149 more layers that will get stacked, baked, and pressurized to create the hardened carbon fiber.
Right now, for the first time, really just seeing what a massive project this is.
It looks like Mike will be spending more time at the doctor's office than he'd like. A couple of days ago, Terry took his layout for the chassis to spec design. Now, Terry takes the completed CAD files over to Top of the Hill to meet with chassis wizard and owner, Craig Hill.
Good, I'm good.
As Terry and Craig go over the designs, they both realize just how big of a project they're undertaking. 19 hours of welding alone need to be done, which means Terry is going to need a refresher course in the fine art of TIG welding.
I have not TIG welded in 15 years. It's going to be a little bit of a learning curve for me. I'm a bit heavy-handed.
TIG welding is an electrical welding process used for light metals, like mini copper alloys, or in our case, aluminum, and allows for very strong welds, which will be essential for the strength of this chassis. After watching an expert perform a few simple TIG welds, Terry dons his mask and joins in on the fun.
Holy cow, that actually goes together pretty good. Guess it's like riding a bike.
Halfway through the first week, with the chassis just starting to come together, Terry realizes what a long ride he's in for.
Well, we got about 200 and something welds to go. This is going to take a while.
Coming up, the chassis comes home. Way heavier than planned.
It's a bit on the heavy side, but we got the job done.
Will this spell doom?
There is absolutely no way we can get this vehicle to walk.
And later, it's the robot's day out. Will it walk the walk? Our team of mad scientists is examining the very foundation of transportation as we know it, the wheel. By attempting to build a six-legged robot that can carry a human, the guys will truly be creating the future of all-terrain vehicles. And they'll be demonstrating their ambitious prototype and the safety of an open field in only 10 days. To give them a leg up on this prototype, the team is using the brains from guest builder Hal's little robot to control their larger version. Up in the lair, Zaz is finalizing a custom drivetrain to work in conjunction with the brains from Hal's small-scale Rex to make the 6x6 walk.
If you look at the video of Rex in action, it looks like it's just spinning those legs around crazily like they were wheels. But that's not what's happening at all. There's a complicated control mechanism that ensures that the legs are synchronized in speed and position, making sure that those legs hit the ground in the all-important alternating tripod gate. What we have here is a complete drivetrain for one leg of the robot. A motor, a gearbox, an encoder, and a power controller.
So Zaz and Hal set up a test, integrating both systems to determine if they can control the movement of the legs. But since Mike's still working on his carbon fiber appendages, they're going to use a replacement.
The classic 2x4.
Zaz attaches the test leg and stands back. They start off simple, first testing their ability to spin the leg. Satisfied, they attempt to control the speed and motion, just as if it was walking.
Yes.
It works, but Hal isn't happy with this slow pace.
Let's increase the speed. Come on, I'm dying for it.
It's alive.
And based on this test, when Mike's legs are attached, the drivetrain should keep the 6x6 moving forward.
It passed with flying colors. We got to the point where we were doing position control of a leg with the brains of the small Rex. We're in a good place now, drive-wise.
But this beast's ability to walk is dependent on the legs being strong enough to support a 400-pound chassis, while also being flexible enough to cover varied terrain. So over at Dr. Carbon Fiber's shop, Mike has finished cutting and stacking the carbon fiber and is ready to move on to the next step, laying the stacks on the mold. The mold is a large cylinder that holds the shape of the carbon fiber in a perfect semicircle. They've got one shot at this. The stacks must be laid on the mold precisely, or they'll have to start again from scratch.
Then we're going to just start putting stack after stack after stack on the mold. You start to see now that these are going to be pretty monster legs, especially when you consider what they're made out of. And this isn't just like a slab of steel here. This is some serious aerospace grade material right here. I mean, we could send this to the moon.
Then it's time for the final step in carbon fiber manufacturing.
The magic cooker.
The autoclave. The autoclave is a large oven designed to slowly heat and pressurize the stacks,
We're good. We're in. We're good.
forming them into a super strong material, sturdy enough to stand up to the pounding it will endure as the 6 legs of the all-terrain vehicle.
Iron hole.
The goal temperature is 250 degrees Fahrenheit, but like any good roasting, slow cooking is better. So for this turkey, the heat is set to rise 1 degree every 10 minutes until it reaches the target temp.
As the temperature rises, it's going to become more of like a fluid. And so all these layers will start to be able to flow together. And as that happens, there's going to be all this pressure pushing down on it. When it gets to a certain temperature, the epoxy, it's going to start to cure. And it's going to become really hard.
With the legs in the oven, it's almost time for Terry's chassis to come home. With the base fully formed, there's just one more step before Terry can take his metal masterpiece back to the island.
Right axle center line.
What is left right now is to get the roll cage, which has already been fabricated,